Many great discoveries and inventions have actually taken place because of man's quest for knowledge and for knowing what else can he achieve in an attempt to progress. And in this quiz, that's exactly what we're going to do. Welcome once again to yet another episode of Quest, the weekly inter-school science show, which is brought to you by the National Council of Science Museums and Diocesan Kendra, Kolkata. And once again, we welcome the director of the Nehru Science Centre, Mumbai, Mr. G.S. Rautela. Let's have a very warm round of applause for him. Hello, sir. Welcome, sir.
Thank you.
And two new teams for us. On my right, the J.C. Bose team are the girls from St. John's Diocesan School, and you are?
Hi, I'm Nandana from Dio.
I am Tapasree from Diocesan.
Hello, I'm Saraswati Mukherjee from Diocesan.
Let's have a big round of applause to them. Welcome them. Thank you. And on my left, the girls from the National High School for Girls, and you are?
Hello, I'm Narupama here.
I'm Kripa Nagarajan.
Hello, I'm Indu Pandey.
Both teams, please note, 20 points, that's if you answer the question within 15 seconds. That's on their direct questions. If you do not answer, they'll move on to your counterpart team, whichever the team may be. If neither team answers, we go to the audience. On passage, you get 10 points. J.C. Bose team, your question. Mr. Rautela.
Yeah, there is a candle which is pivoted at the center, and I am going to burn this candle from both sides. Let's see what happens. Okay, this candle is free to rotate.
Are both lengths equal, Mr. Rautela?
Yes, slightly off balance, but let's see what happens.
Yep.
इसको ढीलेगा, रोटेट करेगा, यानी कि जो है रॉड बर्न करेगा, वही वो ज़्यादा करेगा, समझ में आया?
Okay, you have seen that it oscillates like a swing. Now the question is, why does it happen so?
The seesaw effect.
Well, the flame is always in a perpendicular direction. I mean,
Yeah.
it's always in a perpendicular direction. So when the part of the candle which is coming in contact with the flame, it melts like more faster than the other part.
Yeah.
So it then the weight of this part becomes less.
Okay.
So it moves up,
Yeah.
and when the other part comes down,
Yeah.
and then the part of that candle, that portion,
Yeah.
comes in contact with the flame more than this part.
Okay.
So then the weight of that part is less than this part. So it went up.
You are right. You're absolutely right. You get your 20 points. What's happening is when you tilted one side, the wax on the that side melts more than the other side. As a result, the weight reduces, the center of gravity shifts the other side and goes down.
Yeah.
But that process is repeated, and
So it
again
then it
it
oscillates.
shifts. So it's like a seesaw. We can see this. Okay.
Well, Nandana, with the right answer then, 20 points to your team. The next question will go to the C.V. Raman team. Welcome back. You're watching Quest. Scores right now. J.C. Bose team have already opened the accounts because they answered the first question very correctly. The second question today is for the girls from National High School, that is the C.V. Raman team. Mr. Rotella.
Yeah. The question is, I have two rods, one is smaller, one is bigger, the diameter is same. I'm going to perform small experiment. I try to balance the smaller one on my finger, but I can't. It falls down, but it is much easier for me to balance the bigger stick. The question is why it is possible to balance the bigger stick, not the smaller one.
𝐶𝐞𝐤𝐨𝐬𝐭𝐫𝐚𝐿 वो याद है वो तुम कुछ बोलो गलत बोले सब जल्दी बोलो ना मेरे को नहीं याद है बोल देखो कभी ले
5 seconds. I'm afraid, girls, your time is up. We will have to go across to the other team. That's the girls from St. John's Diocesan School.
Due to the change of the center of gravity of the long two rods.
Can you speak a little louder, please?
Due to the change of the center of gravity of the two rods, it's tough to balance the smaller one, but it's easy to balance the bigger one.
Well, I think no, I won't grant you points for that.
No, Shashwati. Anyone in the audience?
Yes.
Yes, please come up. What's your name?
I'm Abhimanyu Kaur from Pathabhavan School.
Yes, Abhimanyu.
Naturally, as they are made of the same material and same radius, the longer rod is heavier. Now, to balance it, we have to exert a normal force against the weight. Now, if I exert a slight normal force on this smaller one, it will topple, because when I exert a very small force, it gets disbalanced. But this is not the case for this. It needs a larger force. If my hand shakes for very small displacements, this will topple, but this will not, because that force will not topple it, because it is heavier.
Well, that's not the correct answer. Well tried. Anybody else would like to give a better answer?
Abhimanyu, you can go back. I guess, Mr. Rotella, you'll have to tell us why.
Well, it was a very simple question of moment of inertia. See, against my finger, that is a turning point, the pivoted point. Okay, since the moment of inertia of a smaller one is higher than that of a bigger one, you know, because of, all right. So moment of inertia makes this turning or a torque lesser than that for this one, okay. So that's why it is difficult to, torque is developed quicker. In this case, I am able to balance it, all right. So it's a moment of inertia which makes it difficult to balance the smaller one.
Well, no score to either team there. Scores remain exactly where they were. That's the girls from C.V. Raman team are on no score, and J.C. Bose team on 20 points. Welcome back. You're watching the weekly inter-school science quiz, Quest. This is brought to you by the National Council of Science Museums and Doordarshan Kendra, Kolkata. Third question in today's episode is for the J.C. Bose team.
Well, your question is, you see a setup here, there's an inclined track, and then there is a loop, which is perfectly circular in nature. When I drop this ball, it completes the loop once again, despite this track being open from there, it doesn't fall. Now you have to answer me what makes the ball stick to the track.
It's the inertia of motion and the high velocity. Inertia of motion. It's performing such a action just because the inertia of motion, it's falling down under the action of gravity, and at that point it acquires a high velocity, and owing to that velocity and due to the inertia of motion, it just continues this motion and just cancels it's nullify the action of the gravity, and thus is complete.
What is that force which is cancelling the action of the gravity?
Is the centrifugal force.
Centrifugal force, that's right. Okay, you get 10 points.
20 points.
Well, when the ball was dropped from here, at the bottom of the track, the inclined track, the speed is so high that is able to go along this because of the centrifugal force, and it goes into circular path from here. And that now the diameter of this circle and the height from which it should be dropped, it always is very important. From here it will not cover. Okay, and only from a certain height it is able to complete the path. So there is a ratio.
Great answer then, 𝐺𝐶 team. You move your score on to 40 points. Let's have a big round of applause for them. Mr. Rautela, tell me something.
Yeah.
Is this not more or less the principle by which, let's say, a roller coaster would work?
Yes, exactly same. Even the 𝐶𝐞𝐦𝐨𝐬𝐭𝐫𝐚 you see in circus, the motorcycle which goes around a spherical cage, is the same principle. If the speed is so balanced or is so high that it can overcome gravity, and then the centrifugal force can keep it on the track. So in both roller coaster as well as 𝐶𝐞𝐦𝐨𝐬𝐭𝐫𝐚 you call in circus, this same principle applies.
The 𝐶𝐞𝐦𝐨𝐬𝐭𝐫𝐚.
𝐶𝐞𝐦𝐨.
All right. Well, C.V. Raman team, I guess you better pull up your socks because you've got some scoring to do. The girls from St. John's Diocesan, that's the 𝐺𝐶 team, have shot away to a handsome lead of 40 points. Scores at this stage, 40 love. 𝐺𝐶 team 40, C.V. Raman team yet to score. Next question is for you.
I think I have to go forward to demonstrate this experiment. I have two balls of rubber, both bounce. Now, if I drop this, these two balls together, the smaller and the bigger together, what is likely to happen? Can you guess?
लिफ्ट का ही करता है ना, याद है?
I guess let's see what happens.
Yeah, let's see what happens. Then you have to tell me why does it happen.
वो ये चलती
Oh. Can I have the ball back, please?
टुगेदर एक साथ मिल जाता है. ठीक से देखो क्या मिल जाता है.
Once
सेंटर
again.
ऑफ ग्रेविटी
दोनों का एक रहता है.
Good catch there.
अरे
CG is the same.
अरे सुनो वो.
Now the question to you is, why does this ball go so fast and so high?
So fast.
बॉल देखो नीचे करने से उसका एक प्रिंसिपल रहता है, लेकिन जो नीचे वाला बॉल है it also has a tendency to come up. So this pushes the ball.
Both the balls when they are dropped have a tendency to rebound.
Yeah.
Now when you put the smaller ball on top of the bigger ball and you drop them both simultaneously, the smaller ball itself has a tendency to rebound, and this bigger ball, the tendency to rebound supports the smaller ball for rebounding again. So a double force is applied on it, for which it acquires such a high velocity and it bounces forward.
Well, you are right. You get 20 points. But can you tell me, just for my curiosity, could you tell me how high it will go?
It depends now on that.
And in what energy it will go up?
Energy, kinetic.
Nothing to fear, girls.
Kinetic energy.
Yeah, kinetic energy will only definitely have to take it up, but I want to tell you how much.
It depends on the force by which we put it down.
No, we just dropped it.
Oh.
Anyway, they get 20 points when these both balls were dropped together. First, the bottom ball collided. If it is a perfectly elastic collision, it will bounce back with the same speed by which it touched the ground, right? Now, so when the smaller ball on the top, what was the relative speed between two? 2v. One was down, one was up at that moment, so 2v. Now, because this transfers all the energy to that ball, how much speed it gives to the smaller ball? Again v. So total that ball will go with 3v speed. And at it, how many? What will the height? 9 times. So the smaller ball will go 9 times the height from where it was dropped. Okay, so that's the correct answer.
Big hand then for these girls. Score now 40 points to the JC Bose team and 20 points to CV Raman. Next question will be on the buzzer. And now the last three questions. These, as you know, are on the buzzer. Remember teams, plus 20 if you get it right, minus 10 if you get it wrong. Please be ready with an answer when you decide to press that switch. Mr. Rotella.
Yeah, I have three tubes. Two tubes are the same length. One is thinner, but one is little wider. And another tube which is same as the one in diameter, but smaller in size. Now, when I put these two tubes in my both ears, I get hissing sound. But when it's the same, but when I use a smaller one and a bigger one, I get hissing sound, but of a different nature. Can you tell me why does it happen? Yeah.
JC Bose team.
It is because it's a principle of the open pipe. The air is vibrating there, and it what does it depend on is the length of the pipe and not on the diameter of the pipe. And in case of the in the first case, we have that the diameter is different, but the length is same. So we have the same hissing sound. The frequency is the same. But in the second case, though the diameter is the same, the length is different, and it's a factor on which the frequency or the wavelength that we can say depends on. So we are getting sound of different nature.
The frequency of the
you are on the
shorter
dot.
tube
Can you tell me one thing? What is the sound comes from? Why do you get a particular frequency hissing?
It's because the air is from the outside. The air is traveling inside, and it's hitting our eardrum.
Yeah, but why a particular frequency, not the other one?
Why a
It depends on the wavelength.
Yeah, okay. Well, your answer is right. You get 20 points for that. But I would like to add this to it. This is called natural frequency of the tube. The natural frequency depends on the length. So it will resonate to the frequency to which it has the natural frequency, right? So in nature, in surroundings, we have all the frequencies running around. So it picks up, resonates at that particular frequency. That's why you hear only one frequency, not the other frequencies. Okay?
With the scores reading 60-20, that's 60 to the JC Bose team and 20 to CV Raman team. Let's see if CV Raman team can catch up or not. Next question, again on the buzzer. Here we go.
I have a stick which has few notches. At the end of it, with a pin, I have fixed a propeller which is free to rotate. When I rub another wooden stick in a particular position on my fingers, you find this propeller starts rotating. Now the question is, what makes it to rotate when I am not making any rotational speed, or I am not giving any rotational speed? I am giving only a linear speed to the vibration, movement.
Five seconds. I'm afraid neither team going for the buzzer. Yes, you have. Should we take?
I think time is up.
I think
okay, you want to answer? Welcome.
All right, go ahead.
But I mean, every time you appear, give the stick a linear speed, the propeller, I mean that point, that material that you have on the top is in vibration, which is in direct contact with the, with the other material, with the propeller. So due to this constant vibration of the material on top of the stick, this sets the other one into a vibration.
But why the direction of vibration changes? I am giving only linear vibration, it gets a rotational vibration.
What torque के वजह? बोलो कपल के लिए torque के लिए. Is it a torque?
Yeah, but torque is developed, you are right, but how?
Force radius तुम्हारा. Tell them.
What do you say, Mr. Rotella?
I think I would give them a point, at least the word they have spoken.
Okay. Mr. Rotella, can you give us a more detailed explanation?
Yes, I'll explain this. When I'm rotating or rubbing this stick against this, the vibrations, this rod is set into vibration along with the pin which is holding this propeller. Now, since these vibrations are not only in one direction, they are in two directions because of the notches are not uniform, neither my hand is giving uniform motion. So, there are two direction of vibrations develop on the pin, and that gives, because of friction between pin and the propeller rotates in the resultant direction of those two vibrations, and that happens to be a circular vibration, easiest vibration for the propeller, and rotates. That's the correct answer.
Well, girls, you've been lucky there singularly, I'd say, to pick up those bonus points after the time was up. Welcome back to Quest. The very last question on the buzzer, scores reading 60 to JC Bose, 40 to CV Raman team. Anything can happen. Mr. Rotella.
Well, I have 3 beakers with some chemicals. I'm not going to give you the names. I'm going to pour ferric chloride to all 3 of them. Okay? Now you have to tell me, I'm giving the names of those chemicals now to you. Silver nitrate in one, potassium ferrocyanide in another, and potassium thiocyanate in another. Okay? Silver nitrate, potassium thiocyanate, and potassium ferrocyanide. You have to, when I add this, you have to tell me from the color of the precipitate which is what.
White is silver nitrate.
What a nice color. Adding only yellow and we get 3 colors. Yes.
The white one is silver nitrate.
And you have to tell me why also.
Because of the white precipitate that's being formed.
What is the precipitate of?
AgC, silver chloride.
Okay.
AgCl, yeah.
All right.
And the middle one is thiocyanate. And the last one was
Potassium ferrocyanide.
Okay, you are right. You have identified them correctly. You get 20 points. Can you tell me the chemical they are formed in the other 2?
They are complex.
Yes, yeah, I know. They are complex. I am also expecting it's not within your scope, but we will be definitely telling viewers what are these chemicals are and what is the complex in a chemical formula will be given. Okay, so silver nitrate makes a white precipitate, potassium thiocyanate makes a red precipitate, and potassium ferrocyanate makes a blue precipitate. Okay, so that is and when you add, so one drink of the choice you can have 3 drinks.
Well, with a name like cyanide attached to it, Mr. Rotella, I sure ain't having that drink with you.
Sure.
Teams are both tied absolutely even Steven. Final scores, 60 points each. Let's have a big round of applause for both the teams. Well then, in what has been a very high scoring episode of Quest, every question answered correctly. Let's have yet another very big round of applause for all the participants. Scores tied at 60 points each. The girls from National High School, Nirupama, Kripa and Indu. Thank you for being on our show. A small memento for you.
Thank you.
St. John's Diocesan School, Nandana, Tapashri and Shashwati. Thank you very much. We hope you've enjoyed watching this episode of Quest. 60 points to both teams, very high scoring indeed. Please do write in to us with your comments. Our address is Quest, care of Diocesan Kendra, Kolkata, 18/3, Uday Shankar Sarani, Kolkata 95. We'll see you again next week with 2 new schools. Till then, it's goodbye from all of us here